I'm going to make a video showing you how to use some of the features of the TI-36xpro that are useful for your particular class. So this calculator is the TI-36xpro. It's available on Amazon right now. It's available new for $23.04. Usually there's some used ones for under $20. And it is the 36xpro. That's the calculator, TI-36xpro. The demo that I have on the screen, the emulator says 30, but that's what it is in Europe. But in the United States, it's the 36xpro, so that's the one you want. And these numbers are important. If you don't have like the 36 and the X and the Pro, then you're not going to get the one that has all the stuff. So this is the one you want. And I'm going to first show you just the general features that you probably are used to on other calculators. Well, not if you've had to use the one that's required for the calculus classes, which is silly. But if you need to reuse a value from a previous calculation, you can just use the up arrow and highlight it and copy it, and it goes right to the online screen. So you just go up to it, and where it's highlighted, and press enter, and it copies it to the screen. Now if I want to insert something into there, like I forgot to put a minus sign, I use the arrows to cursor to where I want to insert something, and I press second and delete, and that's to insert. You see that the cursor changes, so when it looks like a solid square like that, it overwrites, but when you do second delete and it turns to that underscore, that means it'll insert, and then it'll be in insert mode until I tell it to do something else. So now if I use the arrow keys, it goes back to overwrite mode. Once you have changed something in a line, you don't have to go to the end of the line before you press enter. It'll just go ahead and do it. If I realize that on this one I just didn't need that 2, I can highlight or copy. So I go back, I I highlight it, and I copy it, and then I go to, I don't remember what I just said. I think I said didn't need the 3, so I go over to the 3 and I press delete, and that just erases the 3, and so that's deleted. So I can just press enter, and then I get that. If you, most of the time for this class, you'll want to be in degree mode. You might have to change to radians, but if you press the mode, you can be in degree, radian, or gradient. I don't know who uses that, but we want degrees. You also will want to be probably in real, but maybe in A plus BI, maybe R theta. I'll put it in A plus BI for now. So actually not real, although so A plus BI is good, or R theta, depending on what you want your default setting to be. But you do need to have degrees. And then to get out of this mode, if you ever find yourself in a screen and you don't know how to get out, try second and mode. That's for quit, and that'll get you out of there. A couple other things. I'm a big fan of the fraction button. If you ever have to do big calculations where you want to make sure you have everything in the right place, like let's say you want to know the force between 2 charges of 8.9 nanocoulombs that are 2 nanocoulomb particles that are 2 centimeters apart, then 8, put in the fraction, 8.99 e 10 to the 9th for k times, I already forgot what I said the value of the charges were, but let me do, I'm just going to say 8.2 EE for times 10 to the, so that's nanocoulombs, so that's 8.2 times 10 to the 9 nanocoulombs. That's going to be one charge, and let's say the other charge is, I did not need parentheses there, let's say the other charge is 7.5 nanocoulombs, so times 10 to the negative 9, and I want that to be, it was some number of centimeters apart, I don't remember what I said, so 5, well, delete, I don't want to press clear, that'll erase everything. Delete erases just the number that I'm on, 0.053, that's 5.3 centimeters, close parentheses, squared, that's the squared button, and then I can see it all on the screen, I can see if I have any mistakes, and I can just press enter. There is a constants on here. I usually don't find it so useful because it takes a while to get to the constants that I want, but if you press second and the open parentheses, so like if I needed that that K value, it is not that K value, it is where is it? We've got electron radius, we've got electron mass, we have electron charge. Epsilon naught if you need that. Oh, no. Planck constant. No, okay, well maybe it's not in here. Okay, but if you have values that you use a lot, it can be useful to store them into a variable, and you have the variables you have available are X, Y, Z, A, B, C, D. So let's say that I wanted to store that 8.99 times 10 to the 9th in a variable. So 8.99 EE9 store, and I'm going to store it in, I'll store it in A. So I'll press this button X, press it, oh T, it goes X, Y, Z, T, A. So put in A. And so now anytime I want to use it, if I wanted to have 6 times 8.9 times 10 to the 9th, I just go get A, and there it is. And so you can store all your variables that way if you needed to. Okay, a couple things before I go to the complex number menu, which is I know what you're really interested in, but you do need to see these things too. If you want to solve a system of equations, let's say I had 3 equations and 3 unknowns, you go to second and system solve, which is the tangent button, and if I have a 3 by 3, this would be like I had 3 times V 1 plus 2 times V2 and so forth. So this would be 8. I'm just putting in the coefficients of the variables here, and then the number on the other side. So that's what it equals. And I just put all my values in. And let's say the last equation was just 2x plus 3z. So I put in 2 for the x and 0 for the y and 3 for the z, and then whatever was on the other side of the equation. You press solve and you get an answer. And by the way, it will always give you an exact answer unless you put a decimal in it. If you want to get the decimal version, the button above the enter turns it into the decimal version. And so now we've got the approximate value, and then I can get my values, my 3 values. So if I wanted to solve a 2 by 2, that'd be second, system solve 2 by 2, and this time I put in the coefficients and then either a plus or a minus, and then the next coefficient, and then what it equals, and solve. And again, if I need the decimal value, I just press that. One thing you can do if you know you want a decimal value to start off with, you don't want to bother telling it to convert. Like, let's say I've got I'm doing 5 times 9 over 8 times 6 plus 4 squared, and I really don't want a fraction, then all I have to do is put a decimal at the end of any one of my numbers and just press enter, and it'll give me the decimal version instead of the fraction version. Then there's also polysolve. So if you need to solve a quadratic equation, go to second and polysolve. And so the first one is the quadratic equation solver, and so you can put in your coefficients. Will it work with an imaginary number? I don't think it does. Yeah, it's not gonna. It won't. This will not. That's one thing it does not do, is it will not solve the quadratic with imaginaries, so you'll have to do that yourself. It will give you an imaginary answer. So like right here, I've got a complex answer. Now when I had that complex answer, you can see here, I can see -1/5 plus j square root of 29 over 5. When I change it to the decimal version, I sometimes don't have all the decimals show up on the screen, and you can just use the right arrow key to see more decimals. It will use I instead of j, and it'll put it at the end of the number. And then just use the down arrow to see the next one. And then I can quit. You can store functions. I'm not going to show you all that in this video. Let's see, and there's also a way to store different operations, but I'm also not going to show you that in this video. So now the thing that you probably want, well, one last thing before the thing you want most, just because sometimes people can't find it. If I need to raise something to an exponent that's not squared, it's right there. It gives me that. If I want to take the root of a number that's not the square root, it's one of the few things that you have to type the number first. So if I want to take the 5th root, 5, and then second, and then the root button, and then 9, and then enter. Okay, so now complex numbers. To get to the, if I want 5 plus j3, 5 plus j is, they use the math version of j, which is I, so 5 plus I, 3, and there it is. And I can do anything I want with these. So if I want to divide, 5.3 plus j8 over 8.2 minus j7, enter. It gives me that value. Now again, I can't see the imaginary part, so I'll use the right arrow key to see what it is. So 0.883, and I know that I is at the end of it, so I don't have to go all the way to the end to get that. So it will give you the answer right now in I plus j, a plus b, bj form. If I wanted to change it to polar form, I can, well, if I'm in a plus bi form right now, if I was in a different mode, so if I was in polar mode, and I do the same operation, it'll give me the answer as the magnitude and the angle. And so 0.89. Now, unfortunately, the depending on how big your angle is, the first decimal doesn't show up, and so you don't know if you need to round up or down without. See, that would have been 97 degrees. So so if I'm in polar form, it'll automatically do that for me. But if I usually stay in a plus bi mode. So if I'm in a plus bi mode and I want to change my values, I've got a plus 6j, and I want to change that to polar, I go to second and the complex menu, which is the pi EI, and I go down to R angle theta, and I press that and I press enter, and it changes it to polar form. Now it will, if I don't do anything, if I, let's say that I had this answer and I want to change it to A plus BI, I don't have to copy that back in. It'll just use what my last answer is. So I can go to second, complex, change to A plus BI, enter, and it'll just use the last value. But let's say I wanted to change something else to polar from an earlier operation, then I will go up to where I had it. So I'll take, let's say I have this value and I want to change it to polar. So I went up and I highlighted it. I'll do second, complex, change to polar, and press enter, and then it'll give me the polar version of it. And I can combine different versions in the same operation. So if I wanted to divide 5 angle 32, do 5, and to get my angle, I go to the complex menu, second, and pi EI, and there's my angle, 5 angle 32, divided by 2 plus J 8, enter, and it'll give me the answer in A plus BI form. Or I can go to second, complex, and change to polar form, and so it's 0.606 angle negative 43, negative 44 degrees. It will always give you the right angle here. You don't have to worry about when you take the inverse tangent, you have to worry about whether you're in the right quadrant. This one will always give you the correct angle, so you don't have to worry about that. It does change it correctly. Also in the complex menu, let's see, so we've got the angle symbol. If I just wanted, for some reason, if I just wanted the polar angle, I could do polar angle and then go get the number that I wanted and press enter, and it'll give me just the angle part, so I can do that. I could also get just the magnitude part. What else do we have? You can change from, if you start in polar, you can change to A plus BI. You can get the complex conjugate of something. So if I wanted to take, let's say I had 8 plus 6, 9, no, I can't think of right now why I would want the conjugate of something, but let's just say I wanted the conjugate of something that was in polar form for some reason, so I couldn't easily see what the conjugate was. So let's say I had 5 angle 32, and I wanted the conjugate of that. Notice I'm in overwrite mode, so I'll change to insert mode, and I'll go to second, complex, and I'll get go to conjugate. So conjugate of 5 angle 32, and that would be the complex conjugate of 5 angle 32. That means that 5 angle 32 is 4.24 plus J 2.65. Also in the complex menu, you can get the real part or the imaginary part, so you've got all of those available. Let's see. It will do numeric integration and differentiation, so only numeric, but if I needed to take the integral from 2 to 5 of e to the negative 2x dx, it'll give me that value. If I need to find the derivative of an expression, it'll find the derivative at a particular point. So that's second, and here's the derivative. So I'll put the expression in 8 sine x, and be at x equals, say, pi over 4, enter, and it'll give me that value. One nice thing it does, if I put in, say, sine pi over 6, for instance. Oh, I'm in degrees. So if I put in sine of 30 degrees, gives me the exact answer. Sine of 60 degrees gives me the exact answer. You may not want that, and you may need to turn it into the decimal form, which you can do that way. If for some reason you need to input a mixed number like 3.5 and you just don't feel like figuring out what it is, you can do that. That's second and 7, so 3 and 1/2, and it'll turn it into the improper fraction. Unfortunately, the polysolve and system solve does not work with complex numbers, so that is unfortunate, but it is the way it is. But it does do a lot of other things. And I think that's everything. If you have any questions, feel free to email me. I did remember one more thing. If you wanted to just reuse the answer from the last calculation that you did, so I did this, and then I had a long expression, 5 minus 8 times 6 plus, I wanted the answer from the last expression, and for some reason I didn't want to go up and highlight it. I could just do second answer, and there it is.